we are going to look at modeling with exponential and logarithmic functions. Okay, and those of you know that the word modeling definitely has to do with word problems. Okay, so first we want to practice solving for the variable. So number one, we want to solve for the letter D. Now be careful because you have to watch out if it's lowercase or uppercase. So we have S is equal to 23.5 plus 2 log D. So we have to isolate this term. So subtract 23.5. Then we'll divide by 2. We have S minus 23.5 divided by 2 equals log D. So if you recall, log has an exponent of 10. So we'll rewrite that in exponential form. So 10 to the capital S minus 23.5 divided by 2. All that's your exponent is equal to D. And you're done. You will not get a numerical answer, so it will be in terms of variables. Let's see. Let me write that D again. Okay, number 2, we're solving for the x. So this is 3e to the nx minus t equals 4.2. Please notice all of your variables now are lowercase. Add t to both sides. 3e to the nx is 4.2 plus t. Divide by 3. So e to the nx is equal to 4.2 plus t divided by 3. You're going to ln both sides. So ln of e to the nx is equal to ln of 4.2 plus t divided by 3. And remember, ln is base e, so you get n times x is equal to ln of 4.2 plus t divided by 3. The last step will divide by n. Okay, and so we will write the answer slightly above the problem. So let me choose another color here. We'll go blue. So number 2, your answer is x is equal to, and it's a division, ln of 4.2 plus t over 3, and then that quantity divided by n as in Nancy. All right, so let's solve some word problems. So we are going to talk about growth and decay functions. So for a growth function, the k, which is the coefficient of the t, the variable in the exponent, if it's positive, it's called an exponential growth. If it's negative, it will be an exponential decay. Suppose at 19 years of age, you win $100,000 playing the lottery. So our P is equal to 100,000. That's what we're going to start with. If you would like to have $1 million when you retire, so that's your final amount. A is 1 million. At age 67, determine the average rate. So R, we don't know. What would we need to have to make that much money? So how do you find time? Well, you want to take your age when you're retiring, 67, minus 19, and that's how many years that you're going to have your money earn interest. And that becomes 48 years. So your formula is equal to A is equal to, now, because it's money, we usually use PE to the RT. But let's practice with this. K is a growth model. So A equals PE to the KT. So 1 million is equal to 100,000 e to the r times 48. Divide by 100,000. Okay, so e to the 48r. So again, I can mark out the zeros, dividing by tens. And we should get 100. So I can also go like this, dividing by tens. We can see. All right, let's see. 1, 2, 3, 4. Okay, that's only 10,000, which means I did not type it in correctly. So if you notice, okay, so let me do that again. So let's make sure that I've written these numbers correctly. So 1 million is 1 with 6 zeros. And then we have 100,000 is 5 zeros. So each one I'm dividing by 10. So we get 10 is equal to this. Okay, when it's E, you ln both sides. Remember, ln is an understood base E. So you get 48r is equal to ln of 10, which is a number. Divide by 48. Now, we have to be careful because your rate is a number, not this ln of 10 divided by 48. So if I do this, I get this. 0.04797, etc. So I would round it to 2 decimal places. 0.05 is equal to r. And we have the correct answer. Now, another way we could write that would be, to change it to percent. But I would do r is equal to 0.05, or we could say 5%. All right, so let's look at this. Number 4. According to a study published in 2012, Burmese pythons are becoming the new top predator in the Florida Everglades. Not many animals can stand against these pythons who grow to be 23 feet and weigh over 200 pounds. Okay, 20 pythons were recorded as captured or killed in 1995. So at t equals 0, we're going to say the year is 1995. Okay, so don't substitute in 1995. Time we need to do in terms of so many years. By 2009, so now it's 2009. So how many years later is that? 2009 minus 1995 is 14 years later. So t is equal to 14. So write a function here. So p of t is equal to p naught. That's your initial amount. E to the rt. So p of t is equal to 20 e to the rt. But wait a minute. You know something. 14 years later, you know that p is 378. So when t equals 14, p is equal to 378. So we can use this fact to find r. So 378 is equal to 20 e to the r times 14. And I'm going to switch that order. So we'll divide by 20. Let's see, 378 divided by 20 is 18.9. Yeah, remember mathematicians prefer to have the numbers in front of their variables. We're allowed to switch the order because multiplication is commutative. Okay, so you're going to ln both sides. And so you get ln of 18.9 is equal to 14r. Divide by 14. And we get this. So r is equal to 0.2099. And I think that we round that to 2 decimal places. So r is equal to 0.21. So your formula So we'll put the answer to A right here. So P of T is equal to 20e to the 0.21t. Okay, that's the answer to A. Okay, because here's why. Use the model from part A to predict the number of pythons that will be captured or killed in 2017. Well, how many years is that? Don't plug in 2017. So 2017 minus year 0, which is 1995, gives us 22 years. So P of 22 is equal to 20 e to the 0.21 times 22. So again, this is a calculator punch here. 20 and then second ln. That gives you e. 0.21 times 22. If you have the 83, please put that in parentheses. So you would need to put the 0.21 times 22 in parentheses. So P of 22 is equal to 29.88. So we're going to say P of 22 is approximately 2030. That's how many pythons we would expect to be killed or captured. Number 5. A sample collected from cave paintings on an archaeological site in France shows that only 2% of the carbon-14 remains. How old is the sample? Round to the nearest year. Use the model for radiocarbon dating. Q of T equals Q naught. Okay, let's see how many zeros are there. E to the point. Okay, behind the decimal point. 1, 2, 3, 121. Okay, so let's see. So we've got, keep that a little bit larger. Q of T is equal to Q naught e to the negative. So it's going to be a decay 0.123,121t. Now it says 2% is left. So that's 2% of Q naught. Okay, 2% of Q naught means 0.02 times Q naught. So you have 0.02 Q naught is equal to Q naught e to the negative 0. And then 3 zeros for me, 121t. So watch, if I divide by Q naught, it cancels out. So it doesn't matter how much you start with initially. You have 2% of the initial amount. Okay, you're going to ln both sides, leaving with ln of 0.02 is equal to negative 0.123, 3 zeros, 121t. Divide by that number. Okay, remember, don't divide by the t. I almost wrote that down. Watch out. Just divide by numbers. Okay, and so if we do this on the graphing calculator or, scientific calculator, remember to close those parentheses. Okay, so T is equal to 32,330.77. So I would say 32,331 years. It's not quite, but we're almost there. On some of the math problems, if we want to know like how many, especially say cans of paint or people, or in the previous example, the number of snakes, if you get over a whole number, if you get a decimal, whether it's 0.5 or not, the 5, 6, 7, 8, 9, we want to round up, because if I say I have 23.2 snakes, okay, it's not 23 because it's actually more, so we'd round up to 24. So that's why I'm rounding up. All right, so last example, we are going to look at what is called a logistic problem here. Logistic growth model. Okay, notice there is a horizontal asymptote. Okay? And notice how it's written. It does have an exponential in there, and it's in the denominator. The point of inflection is where you're increasing here. See if I drew that on. Changes to decreasing. That's called the inflection point or point of inflection. And you will see that again if you take calculus. So you can see that it changes direction. And we have a rate of change. Remember, just rate of change is the slope. Okay, we want to evaluate P of 0 and interpret the meaning. Okay, P of 0, if you look at your equation, this means T equals 0. So P of 0 is equal to 3.194 divided by 1 plus 14.589 E. Okay, so let's see what that number is. Negative 0.052 to the negative 0.05 times 0. Now here's what's tricky. This is going to become a 1. So if I do just the denominator mathematically, okay, so I don't miss it. I usually do the numerator and denominator. If I do second E, the negative 0.052 times 0, I'm getting 15.589. Notice that doesn't go away and just become a 1. So watch the math there, because remember, what we remember is e to the 0 is 1. That's what we're using. Any number to the 0 power, except 0, is 1. So 3.194 divided by 15.589 is 0.205 approximately. Now you have to go back and read. This is in millions. So the year is 1990. So in 1990, how do you interpret it? In 1990, the population of LA was population of LA was 0.205 million. Okay, a little over 200,000. Use this function to predict the population January 1, 2016. Okay, but you're starting from the year 1900. Don't plug in 2016. So what do you know? T is equal to 2016 minus 1900. 2016 minus 1900 is 116 years. So we're going to plug in 116. So P of 116 is equal to 3.194 divided by 1 plus 14.589 E. Okay, and this is negative 0.052 times 116. Now, I'd be really careful, especially if you have the 83. Make sure that goes into parentheses. And again, I usually do 2 steps. So let's see, we should have room here. Let me move this up a little bit. There we go. So I'm going to do the denominator. 1 plus 14.589 E to the negative 0.052 times 116. Okay, so we get this. 3.194 divided by, I'm going to go 3 decimal places. 1.035. Because there's 3 in the numerator. And I get so P of 116 is approximately 3.086. So that means that in 2016, the population would be 3.086 million. Oops. Okay, let's see if we, okay, so let's write that in a different color so you guys can see that. We'll go to blue again. Okay. Population in 2016 was 3.08 million. And this is based on this equation here. All right, so that's what we have for word problems or mathematical models using exponents and logarithms. Have a great day.